20 cubic centimeters of 0.8 molar ethanoic acid was added to 40 cubic centimeters of 0.4 molar sodium hydroxide. Both solutions were at 22 degrees Celsius. The highest temperature reached by the mixture is simply was 25.2 degrees Celsius. A. Calculate the heat of neutralization. So delta H is equals to MC delta T, which is the total is 60, so that is 0.06 kilogram multiplied by the specific heat capacity, that is 4.2 kilojoule per kilogram per Kelvin. Then change in temperature is 3.2 Kelvin. Cancel that, that will cancel that, and that gives 0.8064 kilojoule. Moles of that is the first part is done. Moles of ethanoic acid is equals to the molarity, that is 0.8 multiplied by the volume 20 over 1000, and that gives 0.016 mole. Moles of sodium hydroxide is equals to 0.4 by the volume 40 all over 1000, giving 0.016 mole. Now let's calculate the molar heat of neutralization using that. Molar heat of neutralization. That will be if 0.016 mole is able to generate 0.8064 kilojoule watt of 1 mole. That is 1 mole multiplied by 0.8064 kilojoule all over 0.016 mole. That gives 50.4 kilojoule per mole. So since energy is released, it becomes negative 50.4. We can all realize that the value is lower than the one involving strong acids and strong bases. Thermochemical equation. We have hydrogen ion plus hydroxyl ion to form water, and delta H is equals to negative 50.4 kilojoule per mole. So that is the thermochemical equation. Finally, under the same, we can write or simply illustrate this information in the energy level diagram. So the axis so that is x-axis and y-axis. So we have the reactants and products. Again, reactants are of higher energy compared to products because energy is released. Activation energy. Then we have the products. Sodium ethanoate plus water formed from a reaction between ethanoic acid plus sodium hydroxide. Activation energy delta H is equals to negative 50.4 kilojoule per mole. Reaction progress. Enthalpy. So we have ethanoic acid reacting and is reacting with sodium hydroxide. It is not ethanol, that is ethanoic acid. So that is what we have as the illustration in the energy level diagram. The enthalpy of neutralization of 1 molar sulfuric 6 acid and 1 molar of potassium hydroxide was found to be negative 56.5 kilojoule per mole. the enthalpy of neutralization of same molarity of sulfuric 6 acid and same molarity of sodium hydroxide was found to be a lower value. Account for the difference in the values. When we have a weak acid and strong base, and that involving strong acid and strong base, there is difference in the enthalpy neutralization value, in that the one involving strong acids and strong bases must have higher values, while the one involving either weak acid and strong base or strong acid and weak base must eventually lead to lower value, because some of the energy are evolved or used in the ionization of the weak substance, either weak acid or weak base.